Welcome to another Python and AI tutorial. Today we will show you how to perform advanced statistical analysis and predict future data using SARIMA model in Python without coding. We will show you how to generate all this code using Google AI in Google Colab. We have this data of daily sales in Google Sheets. The data pertains to last 4 years. We intend to predict the sales of year 2025 by using SARIMA model in Python. SARIMA stands for Seasonal, Auto-Regression, Integrated, Moving Average. It is a mathematical model based on regression analysis and moving averages to predict future values in a time series. We will create this model in Python, but we will take advantage of regenerative AI and generate code through that instead of writing code ourselves. We will use Google Colab, which has built-in AI that generates code based on description. The feature works exactly like ChatGPT and Google Gemini, plus it is integrated directly into the Google Colab. Therefore, it is more suitable for generating Python codes in Colab. So, first of all, we need to import data from Google Sheets into our machine learning model. We will get the link to this file and copy that link into the clipboard. Once the link has been copied, we will go back to the Google Colab and ask the generative AI to generate Python code to get data from this file and store it into a data frame. After typing what you want, press the Enter key to generate the Python code. After the code has been generated, press the Run button to test the code. The code should display data frame, which should contain the Google Sheets sales data. We can verify this by comparing the data in both files. Now, you can close the AI prompt. We can hide the output by clicking here. And using this option, we can further continue working on data frame. Let's perform some statistical analysis which are required for future forecasting of sales. We will ask the AI to perform add fuller statistics and display them on charts. These statistics will make us understand the nature of data and its properties. The AI will now generate our desired Python code. Let's run this code and see the results. This code should not only perform these statistical analysis on data frame, but also present them on appropriate charts. And here is the result of the AI-generated code, which is exactly what we wanted. You can tell that you no longer need to code yourself when AI can generate exactly what you ask for. The AI has followed our commands to the letter. Now let's see what each analysis means. ADF statistics are used to tell if time series is stationary or not. If value is positive, the data is non-stationary. If the value is negative but small, it is uncertain, and if value is negative and large, the data is stationary. P-value also helps us determine if the data is stationary or non-stationary. The combination of a low p-value and a large negative ADF statistic provides strong evidence that your time series is stationary. Critical values are thresholds used to determine whether the calculated ADF statistic is statistically significant. Since the ADF statistic of -6 is less than all the critical values, we can confidently conclude that the time series is stationary at all these significance levels. Combined, these statistics are called augmented Dickey-Fuller test for stationarity. Here, the critical values are drawn on a chart for better understanding, just as we desired. Next, trend and seasonality have been separated from the time series for better understanding of the data. There is clear indication of seasonality here, with 2 clear ups in a year. Residual shows remaining data after removing trend and seasonality from the time series. And then the actual data is displayed on a line chart. Autocorrelation or ACF measures the relationship between a time series and its lagged versions. In simpler terms, it tells you how much the current value of the series is correlated with its past values. Partial autocorrelation or PACF, similar to ACF, measures the correlation between a time series and its lagged values, but after removing the effect of intermediate lags. This helps isolate the direct relationship between a time series and a specific lag. We can now create a SARIMA model and predict sales for next, say 30 days. Now, let's ask Google AI to generate Python code and create a SARIMA model to predict sales of next 30 days. The code has been generated. Let's run the code and see the result. In case of error like this, run the previous code, and it will likely resolve the issue. Now, run this code again. The issue is gone now. And, as per SARIMA model, these are the most likely sales during the month of January. You can click on this button to display this data on charts. Here is the graphical presentation of predicted sales. You can also convert the data frame into a formatted table. And now you can sort, filter, copy, and download this data as well. This is the end of our tutorial. Thanks for watching. We hope you liked our tutorial. Don't forget to like, subscribe, and hit the bell icon for more insightful tutorials and updates.